This is an extra practice problem on limiting reactant calculations. Feel free to use this to practice and then check your work or follow along. All right, so given a reaction, and if we know the colors of our reactants, which are on the left, and our products, which are on the right, we can use the colors to determine if products have been made. So if we see metallic white or if we see black, we can see that products have been made in the reaction. If we can see purple, that means that there is some of this calcium permanganate left. If we can see silver, that means that there's some lithium left. And when we can see purple or silver, we can see the colors of our reactants. That means that it is in excess. If we can't see the colors of our excess, that means they have been all used up. So we can look at problems like this where we know how much calcium permanganate we have. And in this one, 12.5 grams of calcium permanganate is reacted with 3.2 grams of lithium. What we want to look at is how many grams of lithium permanganate can be produced. So we don't know, looking at this based on the numbers, which one's going to run out first. So we need to go ahead and do two stoichiometry calculations in order to determine that. And so with these problems, calculation number one is that we're going to start with 12.5 grams of CaMnO42. Our second calculation is that we're going to start with 3.2 grams of that lithium. For both of these, because we're asked how many grams of lithium permanganate, both of these problems are going to end at the same spot where we're doing a calculation to figure out how many grams of lithium permanganate will we get. So both of these, we're starting at different spots, but we're ending at the same spot, and then we're going to be able to compare how much each can make. So I'm going to do calculation one first, setting up my molar conversions and using that molar conversion chart as if that helps. I like to show everything all in one step. So this is my starting value. I have 12.5 grams of calcium permanganate to start. If I'm going from grams of calcium, I need to go from grams of calcium permanganate. Then I need to go to moles of calcium permanganate, because once I'm at moles, then I can switch my substance. And so my first step on that is that I'm going to do that gram to mole conversion using our conversion factor. I know that 1 mole of a substance is equal to the molar mass of the substance. So 1 mole of calcium permanganate is going to equal the molar mass in grams of calcium permanganate. So I'm going to just go ahead and calculate what is that molar mass so that I can plug that in, that value in down here. So with that, we've got that CaMnO42. That means that I'm going to have 1 calcium rounding to the nearest whole, so that's 40 plus. I'm going to have 2 manganese. Manganese is Mn. Each of those is 55, so 2 times 55 plus 2 times 4, 8 times 16 for oxygen. So that gives me a molar mass of 278. And so that 278 for that molar mass, I'm going to plug in down here. That's the molar mass of that calcium permanganate. Once I'm now at moles of calcium permanganate, I can now do that mole to mole conversion using the ratio in my, the ratio of the coefficients in my reaction. So taking this, I'm going to want to, I figure out what's going to go on the bottom here by looking at what is on the top here. So I've got 1 mole of, excuse me, I don't know if that's 1 mole yet. I'll look at my reaction in a second. I want moles of my calcium permanganate on the bottom. And then I'm going to want moles of lithium permanganate on the top because that's what my problem asked me for. So where do I find those? I'm going to go up and look and see that, okay, calcium permanganate, I only have 1 mole because there's only a 1 as a coefficient. With my lithium permanganate, though, I have 2 moles in my reaction, so we're going to have a 2 here. Once we're at moles of lithium permanganate, now we can go moles to grams using that same 1 mole is molar mass conversion factor. I want to get rid of moles of lithium permanganate, so that means that 1 mole of lithium permanganate is going to go on the bottom, and then the molar mass in grams is going to go on the top. And I'm calculating the molar mass the same way I did up here. That molar mass for lithium permanganate is 126 grams by adding all of those up. Once I have that work, I can see that my units are going to cancel. So it's whatever was on the top before, I put that unit on the bottom, so they cancel. And so then whatever my top unit is in my last conversion factor, that's what my unit is going to be on my answer. I'm going to go ahead and plug this into my calculator. And by doing that, I'm multiplying everything across the top. And then I'm going to divide by anything on the bottom. All right. With this one, I ended up with 11.3, I'm going to just round to the nearest tenth, grams of lithium permanganate. That is how much product our calcium permanganate can produce. Next step is to do the same thing with our starting value for lithium. So I'm going to go through the same process. I'm ending at the same spot that I did in that first calculation, but I'm going to start with that starting value of lithium. So 3.2 grams of lithium is our starting value. Just like we did above, we're going to go from grams of our starting to moles. And so I know that 1 mole of lithium has a molar mass, or is equal to the molar mass. I can get that molar mass from my periodic table. It's just lithium by itself. So that's going to be a molar mass of 7. Next, I'm in that second step, going from mole to mole. I'm at moles of lithium. I want to get rid of moles of lithium. I want moles of lithium permanganate. So that LiMnO4 is going to go on the top. And I go back up to my reaction to get those. Remember that we had 2 moles of lithium permanganate in our reaction. We also have 2 moles of lithium in our reaction. So now this is going to be a 2-to-2 ratio. Last step is getting rid of moles of lithium permanganate, and we want that molar mass. So 1 mole is molar mass, 126 grams of lithium permanganate on the top. That's my setup. All of my units will cancel. Whatever was in the top is now going to be in the bottom of the next ratio. And I can multiply anything across the top and then divide by anything on the bottom. So I ended up with an answer of 57.6 grams of lithium permanganate. And so I got 2 values from my 2 starting amounts for my reactants. So as we go through and answer these questions down below, we're going to kind of reference our reaction and reference the values we calculated. So how many grams of lithium permanganate can be produced? Well, when I'm looking at this, my limiting reactant, I want to look at what's going to run out first. I'm not looking at the values that I start with. I'm looking at comparing the values that they're able to produce. My calcium permanganate, 12.5 grams, could produce 11.3 grams of product. My lithium, 3.2 grams, could produce 57.6 grams of product, while our calcium permanganate produces less, meaning that that is going to run out first. And once it runs out, it's not going to continue reacting. So how many grams can be produced? Whichever of our smaller 2 values, that's the maximum that can be produced. So 11.3 grams of lithium permanganate. That's the maximum amount that can be produced. Now we can look at this. Well, what is our limiting reactant? Our reaction stops after that 11.3 grams is produced. So we've got our, what is the reactant that produces that? Well, that came from our calcium permanganate reactant. So our limiting reactant was that calcium permanganate, CaMnO4 2. Our excess reactant, well, we had more than enough lithium. It was able to produce a lot more. So lithium is our excess reactant. And as we look at this last question, what color would you expect to see after the reaction based on this information? We would expect to see some product form. We would see metallic white, and we might see black, or we would see black. But if we have limiting and excess reactants, I have lithium left over. So that means I would expect to still see lithium in my beaker. So I would still expect to see silver in my beaker that hadn't been used up. If my numbers had flipped, and if my number for lithium was smaller, making lithium my limiting reactant, that would make calcium permanganate our excess, so we would still be able to see purple. Hopefully this helped. Please reach out with any questions. Good luck.